Hello student, in this lecture we have to teach the solar heat transfer. In heat transfer they have three types: conduction, convection and reflection. In previous lecture we have to teach the basic unit and dimensions of heat and temperature. Next point, the concept of heat and the laws of thermodynamics. They have four laws of thermodynamics. First one discuss zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics and last one third law of thermodynamics. Hello student, in this lecture we have to teach the solar heat transfer. In heat transfer they have three types: conduction, convection and reflection. In previous lecture we have to teach the basic unit and dimensions of heat and temperature. Next point, the concept of heat and the laws of thermodynamics. They have four laws of thermodynamics. First one discuss zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics and last one third law of thermodynamics. In this lecture we have to first one discuss introduction of heat transfer. Then another one point, types of heat transfer. In types of heat transfer they have three types. First one conduction, second one convection and third one reflection. Then another one point we have to discuss the conductivity heat transfer. In this point we have to discuss the Fourier's law, and the last one point discuss the Stephens-Boltzmann relation or Stephens-Boltzmann law of radiation. In this point, reduction of heat transfer, transfer of heat by thermal energy or heat energy, we have to discuss in this topic. First one, introduction to heat transfer. The first point is reviewing heat thermal energy. In this point, heat thermal energy is created by the movement of particles, atoms that produce heat. Means the heat or thermal energy is created by movement of particles that produces heat. Heat or thermal energy increases by temperature increase, because as the temperature increase atoms move faster, have more kinetic energy. Means the heat energy increases as a temperature increases, means atom moves faster because have a more kinetic energy of these atoms. Then another one point, transfer of heat or thermal energy. The heat or thermal energy is transferred from one object to another. When the objects are at different temperatures, means the thermal energy is transferred from one object to another object. object is different or object are at different temperatures. Okay. The amount of heat or thermal energy that is transfer when two objects are brought into contact depends on the difference in temperature between the object. Heat is transferred only when two objects are at different temperature. Means heat is transferred only when two objects are at different temperatures. When thermal energy always moves from warmer to colder object, means thermal energy or heat is always moves from warmer to colder objects. Okay. The warmer objects less thermal energy and become cooler as a cooler object gain thermal energy, means the warmer object is loss of thermal energy and the cooler object is gain the thermal energy and become warmer. Energy will continue to move from a warmer object to a cooler object until both have a same temperature, means the energy will be continues to move from warmer object. Energy is continues to move the warmer object to cooler object, but we have to move because the same temperature, the warmer object and cooler object, they have same temperature, the energy do not move or do not pass the warmer to cooler object. Okay. Heat transfer is a physical process involving the transfer of heat from hot area to cold area. Heat transfer occurs due to temperature difference. Temperature difference, that is driving force between the point where heat is received and where heat is originating. Heat is received and heat is originating. Heat always tends to flow from point of high temperature to point of low temperature, means heat is always flows from high temperature to low temperature. It is a unit operation, means heat transfer is a unit operation. It is always combined by another unit operation in practice such as heating and cooling of solid, liquid and air. Next one, refrigeration. Third one, evaporation. Fourth one, drying, and last one, distillation. These processes are to transfer the heat by another unit operations, or one operation heat transfer from another unit operation. In this point, we have to teach the types of heat transfer. They have three types. First one, conduction, convection and last one, radiation. Three mechanism of heat transfer: conduction, convection and radiation. In this shown in figure, wood is heated or heat is transferred from convection, conduction and radiation. In another figure, the conduction means the energy is transferred by direct contact. Energy is transferred by direct contact. The second type is convection. The convection is energy transferred by the mass motion of molecules. Second type, the energy transfer by the mass motion of the molecules. And last one, energy is transferred by electromagnetic radiation. Energy is transferred by electromagnetic radiation. Now, a first one discuss with conduction. When heat flows in a body is achieved by the transfer of momentum of individual atoms or molecules without mixing, such a process is called as conduction. Conduction means when heat flows in a body which achieved by the transfer of momentum of individual atoms or molecules. Okay. Individual atoms or molecules without mixing, such a process is known as conduction. Okay. It takes place solid and fluid whose momentum is restricted. When or it takes place solid and fluids whose momentum is restricted. For example, iron rod such as a metal wall of an evaporations. There is no actual momentum or there is no actual movement of molecules on receiving energy from surface of heat. Molecules vibrates and pass of energy adjacent molecules. Okay. There is no actual momentum of molecules, means the actual momentum of molecules there is no, but on receiving energy from surface of heat, molecules vibrate and pass on energy to adjacent molecules. When both ends have same temperature, heat transfer is stopped. Driving force is a difference of temperature between the driving force. Difference of temperature between two ends. The conduction is the transfer of heat. From one part of a substance, to another part of a substance, or from one substance to another, is or in physical contact with it. Without appreciable displacement of molecules forming the substance, that is known as conduction, is another word or another statement. In solid, the heat is created by the following mechanism. Okay. Heat is created by the following mechanism in solid. Okay. First one, lattice vibration. And second one, transport of free energy. Transport of free electrons. In here, one of the example or one of the question, why is conduction easier in solid and liquids? Okay. Why? The figure shows the atoms is vibrate. Okay. Atoms and molecules are closer together in solid and liquids, means in figure shown that the molecules closer together, okay, in solid or liquid. So, the particles need to move only a short distance. When the particles need to move very or only a short distance before they have bump into one another and transfer energy, means one particle to jump another particle. That is why the transfer energy. Okay. In figure showing that the particles is vibrates or moves from one to another. Now, I discuss with second type of heat transfer, convection. When heat is flow is achieved by the actual mixing of warmer portion and cooler portion of the same material, the process is known as convection. Okay. Means two portions, first one warmer and second one cooler of same material. This mixing of two portions, that is known as, or this process is known as convection. This process is known as convection. Okay. There is actual physical movement of molecules. It take place in same fluids, that is liquid and gases. Convection is a heat transfer by mass motion of fluid, such as air or water. When the heated fluid is caused to move away from the source of heat, carrying energy with it. Convection is heat transfer by mass motion of fluid, such as air or water. When the heated fluid is caused to move away from the source of heat, carrying energy with it. The convection that occurs about a hot surface. Convection occurs about a hot surface occurs because hot air surface or hot air expands, become less dense and rises and is called natural convection. Convection associated by breeze, pump or fan is called force convection. Hot water is likewise less dense than cold water. Okay. Hot water is likewise less dense than cold water, and rises, causing convection currents which transport energy. If hot water and cold water, if hot and cold liquids are mixed, the heat and transfer from hot liquid to cold liquid by physical movement of molecules, This method of heat transfer is called as convection. Okay, it is called as convection. In showing figure, that is the convection, for example, that the convection. Another one point or last type of heat transfer is radiation. Okay. When flows through the space, when heat flows through the space by means of electromagnetic waves, such a energy transfer is known as radiation. Okay, means heat flows through past the space, or heat flows through past the space by means of electromagnetic waves. Such a energy transfer is known as radiation. Okay, radiation. For example, black surface absorb most of the radiation received by it, and simultaneously the absorbed energy is quantitatively transferred in a heat or into the heat, that is the radiation. The hot body emits radiation or radiant energy in parallel direction. If this radiation takes a receiver, then part of may be absorbed and part of it may be reflected. Part of may be absorbed or part of may be absorbed and part of may be reflect. This method is of energy transfer, it is called as radiation. For example, example in which radiation is utilized for processing heat. First one, solar heaters. Second one, solar cookers. Third one, microwave ovens, and last one, microwave cookers. These are example of radiations or radiation heat transfers. To start with conductive heat transfer by Fourier's law. In this point, the conductive heat transfer by Fourier's law. Heat can be flows only when there is a temperature gradient, that is, heat flows from a hot surface to cold surface. Okay. Heat flows from hot surface to cold surface. Thus, basic law of heat transfer from or transfer by conduction can be written in the form of rate of equation as follows. The rate is equal to driving force upon resistance. Okay. This formula or this equation is used to find out the rate, that is the rate is equal to driving force upon resistance. Okay. That is why the resistance is also find out. Resistance is equal to thickness of surface upon the mean proportionality of a constant area, mean proportionality of the constant area of a surface, that is formula to use resistance, and resistance are used to find out the rate. Now, a statement of this Fourier's law. The rate of flow of heat through a simple homogeneous social is directly proportional to the area of section at right angle to the direction of heat flows, and to change of temperature with respect to the length of the path of the heat flow. That is the statement of Fourier's law. This statement, the rate of flow of heat through a simple homogeneous social is directly proportional to the area of section at a right angle to the direction of heat flows, to change of the temperature with respect to the length of the path of the heat flow. This is the Fourier law statement. Okay. The Fourier laws can be mathematically expressed as rate of heat flow is equal to area into temperature difference, area into temperature difference upon thickness, that is the rate of flow of heat flow, rate of heat flow. This is the mathematical expression for Fourier's law. That is equal to Q is directly proportional to A up into dt upon dx. Q is equal to heat transfer through a body per unit time. This is watt. A is surface area or cross sectional area, that is the meter square. D by dt is a temperature gradient, that is the K by M. That is why the Q means heat transfer or transfer of heat is equal to minus K A into dt upon dx, where here K is thermal conductivity. K is thermal conductivity, that is unit of W upon mk. W upon mk. This equation of Fourier's law is mentioned the negative sign. This negative sign indicates that the heat flow in a direction along is a decrease in temperature. This negative sign indicate that. Now discuss with radiation. In previous slide I have, or previous point I have also discussed radiation, but in this point we have radiation by Stephan-Boltzmann law. This statement is the radiation heat energy emits by a body is directly proportional to the fourth power of the absolute temperature of total body. Okay. In this here the statement, the total radiation heat energy emitted by a body is directly proportional to the fourth coordinate of power of the absolute temperature of a total body, that is the statement of Stephan-Boltzmann law. The amount of heat radiation emitted by a body increase rapidly with increase in its temperature, That is why, or as per the statement of Stephan-Boltzmann law is, that radiation heat energy emits by a body is directly proportional to the fourth power of absolute temperature by a total body, or of a total body. That is the statement of Stephan-Boltzmann. Q radiation is directly proportional to the T raised to 4, or absolute temperature raised to 4, where T is expressed in Rankine, or that is the degree R. Okay. Degree R or degree Rankine is equal to degree Farad plus 460, degree Farads plus 460. That is why the Q radiation or heat transfer radiation is equal to 0.173 into A in bracket T upon 100 bracket raised to 4. That is the Stephan-Boltzmann law of radiation. This equation is expressed as the Stephan-Boltzmann law of radiation. When two black body, where one is hot and another is cold, first one hot and cold body, the temperature of hot body is T2 and the area is A2, cross sectional area is A2, and the cold body temperature is T1 and area is A1. Okay. That is why T2 is greater than T1 or T1 is less than the radiation heat absorbed by the cold body, cold black body, is Q1. This Q1 is equal to, the formula of Stephan-Boltzmann law is also used to Q means Q1, that is the first value we have calculate. Radiation heat absorbed by a black body is Q1. Q1 net is equal to 0.173 into A1, that is the first body A1, in bracket T2 upon 100 bracket square minus T1 upon 100 bracket raised to 4, means T2 hot body temperature is minus that cold body temperature. Okay. And next one condition is the radiation heat absorbed by cold body is Q2. Cold body is Q2. Q2 is equal to 0.173 into A2. Cross sectional area is A2 in bracket T2 upon T1, T2 upon 100 bracket raised to 4 and minus T1 upon 100 bracket raised to 4 into FA F base AE, means where FAE is correction factor. FAE is correction factor. Student assignment: an oil cooler in a high performance engine. An oil cooler in a high performance engine has an outside surface area. Outside surface area is 0.12 meter square and a surface temperature of 65 degrees Celsius. At any intermediate time, air moves over the surface of cooler at a temperature of 30 degree Celsius. Gives rise to a surface coefficient equal to 45.4 watt per meter square Kelvin. Find out the heat transfer rate. Find out the heat transfer rate. This assignment we have to send the my email vishalshinde@ktgmcollege.ac.in. In this lecture we have to discuss first one, introduction of heat transfer. In types of heat transfer we have three types. First one, conduction, convection and radiation. In another one point we have teach the conductive heat transfer. Okay, conductive heat transfer by Fourier's law. And last point is discussed with the radiation. The radiation with Stephens-Boltzmann law. Radiation with a Stephens-Boltzmann law. In previous lecture we have to teach the heat transfer between gray surfaces, and also discuss another one point, radiative heat transfer by sky radiation, and also we have discussed the another one point, radiative heat transfer coefficient.